we're going to look at polynomial functions, quadratic functions, graphing techniques, completing. We're not going to do completing the square. The vertex formula and quadratic models. So basically, polynomials are identified by their degree, and the degree is the highest power within for the variable. So here, f of x equal to 2, the constant is 2, the degree is 0. So this would be like saying 2x to the 0 power. Next is 5x minus 1 is a linear function that has a degree of 1. So this would be considered x to the first power. The coefficient is 5. Next is a quadratic function, has an x squared to it. So you look at the leading term for that. And the coefficient is 4. Next leading term is 2x to the third power, so the degree here would be 3, and that would be a cubic function with a leading coefficient of 2, whereas the other one is a quadratic function, leading coefficient of 4, and has a degree of 2. Next is a quartic, the leading term, where it has x to the fourth power, and so this would be a coefficient of 1. Questions with that? Okay, function is a quadratic function if it has the x has the highest power for x is x squared. Okay, so quadratic basically looks like a U shape, like a satellite dish shape function where positive x squared opens up. And this bottom point here, the lowest point, is known as the vertex. Notice this is rounded off right here. Okay, next, parabolas are symmetric with respect to a line, and this line is known as the axis of symmetry. The axis of symmetry goes through the parabola at what's known as the vertex. The vertex, if the parabola opens up, the vertex is the lowest point for y values, and if it opens down, the vertex is the highest point for the y values. Now the axis of symmetry acts like a mirror. So however far the distance is from this axis of symmetry out to one side is the same distance out to the other side. Where y values are the same, the x's are going to be the same number of squares out from the axis of symmetry. Okay. So the basic graph, or what I like to call the parent graph, is x squared. So you're going to see in parentheses where you have a number outside. If that number is positive, the graph's going to open up. If the number is negative, that graph is going to open down. And that's what we showed here. So this opening down would give you negative x squared. Opens up, gives you a positive x squared. If this a is larger than 1, then it's going to narrow the graph or make it vertically stretch. If it's a fraction form, whereas an absolute value is a fraction, something that's less than 1 but greater than 0, then it's going to widen out the graph. This x minus h inside parentheses is going to make it shift to the right, so it's going to make it do opposite of what it does outside of the parentheses. Plus k is going to make the graph move up or down. If k is positive, it moves up. If k is negative, it moves down. So h and k are the x and y components of the vertex. which is what we showed here in red. Okay, so let's take a look. So in here we have x squared minus 4x minus 2, and they show a parabola with its points to it. Notice x is positive, the graph opens up. The vertex, because it opens up, the vertex is at its lowest point, 2, -6. The range, or the domain rather, is going to be all real numbers from -infinity to infinity, because it's going to move forever to the right, forever to the left. The range, however, is the h, or the k component, or the y part of the vertex. So notice the range is the same number as the k part of the vertex, or what we kind of know as the y value, y coordinate. And so this would be -6, and it keeps going up to infinity. Okay, so here in green is a positive x squared. Notice it opens up, and with y equals to 1/2 x squared in red, notice it widens out. Negative 1/2 x squared, because it's negative, it's going to open down. And so when it opens down, domain is still going to be -infinity to infinity, but the range is going to go from -infinity up to 0 and then back down again. Okay, so the first one, where we have f of x equal to ax squared plus bx plus c, that's known as this general form of equation. Here where we have a equals to x minus h squared plus k, that's standard form. Okay, so that's all we need to know there. Okay, so basically we want to look at this graph here. We want to see, given the domain, we want to graph the function, give the domain and range. So we're given f of x equals to x minus 4 parentheses squared plus 3. Okay, so we want to graph and give domain and range. Okay, so let's see what this looks like. So go to our sketch here. So because this is inside, this is going to make the graph shift to the right 4 spaces, and because it's plus 3 outside, it's going to shift up 3. So if you look at the parent graph, where y equals to x squared, here we have this vertex hk. This is going to make this point shift right 4 spaces and up 3. So the number inside the parentheses, that's our h. The number outside, that's our k component to the vertex, hk. H is always going to be with x. The k part component of the vertex is always going to be outside. So we're going to take that and we're going to shift it right 4 spaces. So this will be 1, 2, 3, 4, and up 3. 1, 2, 3. So this vertex is up here at 4, 3. And it's gonna, because it's positive, it opens up like that. And so the domain for the vertex is always negative infinity to infinity. The range is always the y part of the vertex, or k. So that's going to be 3, and that's always closed. Because it opens up, it's going to go to infinity like that. Okay, any questions with that? Alrighty, so let's continue on. Alright, here we have 1 minus x minus 1 squared minus 5. And x minus 1 parentheses squared minus 5. Alright, well, let's see why it looks like that. And so we're going to graph it. Okay, here we want to determine the domain and range. Alright, so just for practice, this is because it's inside, it's going to shift. Again, it's going to shift right. This time 1 space and down 5 spaces. So this graph shifts right. Instead of being at the origin, now it's going to shift right 1 and down 1, 2, 3, 4, 5. Okay, so the domain is always going to be negative infinity to infinity. The range, and so this will be, this vertex is going to be, this is h and k. H, k. So h is, because it moved right 1, that's positive 1. K is a negative 5. So the sign changes inside the parentheses, but does not change outside of the parentheses. So the range is going to be the k part of the vertex. So this would be negative 5, and because it's opening up, it's going to go towards positive infinity. And it's going to be closed because this is a definitive point. So it'll be, it includes negative 5 and it moves up to infinity. Alrighty. Any questions with that? Sketch the graph of parabola. Okay, so let's take a look at the next one. We've got y equals to negative, and then parentheses x plus 4, parentheses squared plus 6. Okay, because it's negative, it's going to open down. So we already know it's going to open downward. Because it's plus 4, it's going to be the opposite. It's going to shift 4 spaces to the left. So that'll be left 4 spaces and up 6. So this would be 1, 2, 3, 4, and up 1, 2, 3, 4, 5, 6. So here's negative 4, 6. and opens down. We're not going to get into y-x or the intercepts on this lesson. So the graph is going to look something like that. Domain, always negative infinity to infinity. The range is going to be your y part of the vertex, which is going to be 6, but because it opens down, it's going towards negative infinity for the y's to 6, and then it's going to be closed at 6. So in this case, the negative infinity goes first. Okay. Any questions with that? All right, the next one, we've got y equals to 2, and then x plus 2, close parentheses squared, minus 3. The 2 is, because it's positive, right, opens up. The 2 is going to make it vertically stretch. Because it's x plus 2, it's going to shift left 2, and because this is outside, it'll be down 3. So it opens up. So we know it opens up, and it's going to shift to the left 1, 2, and down 3 1, 2, 3. So from here, negative 2, 3, and it opens up because we said it's positive. So it's going to look like that. The vertex, negative 2, negative 3. So the domain, again, negative infinity to infinity, and the range closed at negative 3 to moving going up, so it's going to be negative 3 to infinity. All right, so let's take a look at one more from this page, and we've got here a y equals to 3 halves x squared minus 4. Now there's no parentheses here, so it's not going to move right or left. So this is only going to make it shift down 4 spaces. And because this is positive, going to open up. Now because this is 3 halves, it's actually going to make it vertically stretch because it's greater than 1. But we don't really need to worry so much about the vertical stretching or compressing on this lesson. Okay, so basically it's going to just shift 1, did not move right or left, so it's just going to shift down 1, 2, 3, negative 4. And we said it opens up. So it's just going to open this way. And so the vertex, because it did not shift right or left, the h part is 0. K is going to be negative 4. So therefore our domain, again, negative infinity to infinity, that doesn't change. The range, because it opens up, is going to start at the y part of the vertex, or k, at negative 4 to infinity. And it's closed at negative 4. Okay. On this next slide, find the vertex, or actually find the x-intercepts. Okay, the x-intercepts are where it crosses the x-axes. So in this case, the intercepts are going to be at 0 and 2. X equals 0 and x equals 2. And that's all you had to do there. Okay. All right, and then the last slide, identify the vertex. All right, let's look at this one here. There's two of them. So you've got here f of x equals to x minus 3 parentheses squared plus 9 and 13. F of x equals to x plus 8 squared. Okay, and we want to identify the vertex. That's all we want to do. So it helps to look at our original equation of f of x equals to a times x minus h parentheses squared plus k, where the vertex is hk. So the h is going to be the number that's inside the parentheses with x. So in this case, the vertex is going to be, because this moved right 3, it's going to be positive 3. And because this shifts up 9, this will be positive 9. So we're looking at these two numbers for h and k. Whatever is opposite of what's in the parentheses is going to go inside for the vertex. Outside the parentheses is going to be the same sign. So this is our answer for 12. All right, let's look at this next one. Well, again, we're using f of x equal to ax minus h parentheses squared plus k. Well, in this case, there's no plus or minus number out here. So we can put plus 0. So we look at the opposite of what's inside here. So here the vertex is hk. So in this case, the vertex is going to be a negative 8. But because there's no number outside here, it's not going to move up or down. So that'll just be negative 8, 0. And that's all there is to this lesson.